Okay, so when it comes to the ellipse, let me highlight the things that we are going to focus our attention on. We'll look at the definition. Okay, um, we'll look at the definition. We're going to look at deriving the standard equation, deriving the standard equation, and what else am I going to look at? I'm also going to highlight other properties of the ellipse. Okay, so when it comes to properties of the ellipse, there are just some certain things that you might want to take into consideration when you are dealing with an ellipse. Either like they ask you to sketch, but usually it's just about sketching. Okay, and I I can I can't overemphasize this. Don't neglect the definitions. Okay, try your level best to make sure to say you know the definitions at your fingertips, because it is possible that they can ask you in an assessment to define what an ellipse is. They can ask you to define a parabola or a circle, or even maybe other conic sections as well. And one thing is that if you observed how we derived the equation of the parabola in the previous session, you are able to understand to say the equation itself is just more like it just comes from the definition. So sometimes maybe you might have forgotten how to derive, but if you really understand English and you understand the definition, it's much easier for you to derive the equation. So here's a definition of the ellipse. Okay, let me try to see if I can quickly type it. um, it's a set, let me say the set since they are known, the set of all, okay, the set of all points, the set of all points, then the sum of distance uh, whose distance from fixed two fixed points is a constant. Okay, so this is the simple definition of an ellipse. So even as we derive the equation of an ellipse, it's just going to come from this same definition here. We say is the set of all points where we say the sum of whose distance from two fixed points is a constant. Okay, so let me try to put this somewhere up here on top, and you're going to see this making a lot of sense from what we are going to how we are going to derive the equation. So we have to save this right here. I'm going to do this. We'll attend to it a bit later. Okay, so that is what basically the definition is. So when it comes to deriving the equation of the ellipse, um, one thing is that the ellipse, the equation that we are going to come up with, let me give you in advance. Okay, the equation that you're going to come up with is it's going to be something like x squared divided by a squared plus y squared divided by b squared is equals to 1. So this is what we are going to end up with, and this is when the center of the ellipse is at the origin. But I also give you other properties such as when maybe the center is not at the origin. So let me try to make sense out of this definition that we have put across here. So let's say we have that as our horizontal axis and that as our vertical axis. So now this, of course, we know is our y-axis and that is our x-axis. So if you look at the definition, we say it's a set of all points, okay, then the sum of whose distance is from two fixed points. So what it is here is that I can temporarily draw an ellipse. This is how an ellipse looks like if it's along the x-axis. Okay, it's going to be something like that. It's not really perfect, but of course when you're using a pencil, this will be much better. Okay, something like that. I believe we have come across a lot of shapes that have an elliptical shape. Okay, so what I mean by this definition saying is a set of all points where the sum of whose distance from two fixed points is what is a constant. What we mean is that if I pick a point here, let me name this as point A. Okay, then let me pick those two fixed points. I'm going to put one here and one here, and those fixed points we call them we say they are is called what the foci. Is the focus. The foci is just more like a plural singular focus, where we have our f1 here, our f2 there. We have our focus 1 and our focus 2. So foci just represents the focus. So this one, we're just saying we have what we have the focus. There are two of them. Okay, so now what the definition is trying to tell us is that if you pick, let's say, a point here, let me say this is point B, let me say this is point C, I can choose another point here, let me say this is point D right here. So try to observe what I'm going to do. Let me actually use different colors. Let me use yellow for point B. Let me use blue for point C, and let me use black. Let me not put it there, let me put it somewhere here. Let me use black for D. So what this means is that when we say the sum of whose distance from two fixed points is a constant, is that if I do this, I put a line there from D to F1 and from D to what to F2. Then I also get the distance from F1 to A and from A to F1, same as the distance from what from B to F1 and from B to F2 there, same as the distance from C to F1, as well as from C to F1 to C, F1 to C, and C to F2. So what it is here is that the way I can write this, if you went through the notes that I sent you, those notes are very simplified and very clear. So the distance, if you look at if I say f the distance f1 to C, okay, plus C to F2. Okay, if I let me just try to write it a bit somewhere this side. So the distance f1 to C, okay, then if you add it with what the distance from C to F2, what I mean is that you get this distance, you add it with this more distance here. This is going to be equals to some number which you are going to be representing as what as a constant. Okay, we're going to be representing as a constant, which we indicate using 2a. Okay, so which is the constant we'll be indicating using 2a. So even if I get let me say I get the distance f1 to B plus B to F2.
Mr. Aaron, come again. I'm behind. Just I'm behind.
On which part?
I can just from the equation you are trying to drive here.
Okay, so I say this is how the equation of the ellipse is going to appear. But what we do is that when you look at the definition, it's saying it's a set of points, the sum of whose distance from two fixed points is a constant. So those two fixed points I'm talking about is the f1 and the f2. That's the foci. It's the combination of the you have two focus 1 and focus 2. Those are the two fixed points that we are talking about in this definition, which is this part of the definition. Okay, those are two fixed points. So what it is that I'm saying, if you pick any point on the more like the perimeter of the ellipse, like on the edges of the ellipse itself, if you pick any point there, okay, so just like I picked A, then I say the distance f8 f1 to A as well as A to F2 is equals to a constant, and that constant we are going to be indicating it using what? Using 2a. Okay, So that constant is indicated using 2a. How the 2a comes about, let me show you.
Yes, now I'm understanding. Got it now.
Let me try to show you how the 2a comes about. Okay, so if you look at what points can I pick here. uh, okay, if you look at this portion here, okay, if you look at that portion there, let me um, let me try to look at the which random points can I pick between the two. Okay, so let me do this. I'm going to put a point here and a point here. Those are just more like we're going to be calling these as our vertices. Okay, so let me use the letter A. Since I've used A here, you observe to say if you put coordinates, okay, you observe to say I'm going to use A for the x-axis, and that will be A comma 0, meaning I have A in the x-axis and 0 in the y-axis, isn't it? Then if you look at that other point, it's going to be negative A comma 0, which makes a lot of sense because on this side the x-axis is negative. So I'm using A. You can use any other letter. So for example, if I use B, I'm going to indicate this as 2B. Okay, but I've chosen to use A, and that's more like the one that they use most of the times. Okay, so if you look at this line here, this straight line, like the distance from, let me name this as my Z, then this as my Y. If you look at the distance ZY, if you want to find what the distance is, the distance ZY is equals to, so this one we just use the same equation for, that thing, for the one that you use for finding distance. So you're going to say the x coordinates, you subtract them, that would be like minus a squared plus, then the y coordinates, which are 0 minus 0 squared, like that. This would just be something like um, this would be minus 2a squared, like that. Okay, minus 2a squared. Then this can get down to be something like it's going to be 4a um, 4a squared. And you believe, I believe to say you understand, this is just basic algebra. This you just end up with what? You just end up with 2a. That's where the 2a is coming from. So what I'm trying to tell you is that the distance from f1, for example, f1 to c, and from c to f2 is the same as the distance zy. Is that making sense?
Yes, it's making sense.
Yeah, so that's where this constant 2a is coming from. So what it means is that even if you pick even if I come and pick, let's say f1 to d, then I say plus d to f2, this distance is still equals to zy. And what is zy? Zy is 2a. Okay, so understanding this fact here is what is going to help us to come up with this equation here. So don't take this for granted. It's not always when they can ask you to derive the equation of an ellipse or any conic section, but sometimes they might just ask you. So you have to make sure to say you know how to do it, just in case they ask you, because these are basically free marks, and you can't afford to lose such free marks, to be honest. So what it is that you're going to put up coordinates for yourself. So to make this simple for myself, what I'm going to do is that I can pick any, either it's A, B, C, or D, to derive the equation. So I'm going to use A. Let me say on my A here, A has the coordinates x comma what? X comma y. Then what about F1? F1 is going to have the coordinates, we are going to use C comma what? C comma 0, like that. Then F2 is going to have C comma 0, like that. So what it is that I'm using C because when it comes to conic sections, the letters that we use the most is A, B, and C. We use C for the focus, we use A for the vertices, and B for the core vertices. Okay, but sometimes there are times when you can swap, in place of A you can use B, in place of B you can use A. So that's why on the focus I'm using C. If I was finding the vertices, I could have used A. So now let's try to see this. We are saying f1 to c plus, in fact, let me use, here I'm going to use f1 to a, okay, plus a to f2. This is supposed to give me 2a, like that. So I'll not use any of these, but even if I was to use those ones here, those ones that I drew at first, you're still going to end up with the same thing anyway. So look at f1, I mean f1 to a. So from this point to this point here, it's just something very simple, and I believe we have been doing this from like from primary school, finding the distance. So I'll put that, then I'll put another one. Okay, so this is supposed to be equals to 2a. So for this portion, I'm going to use for f1 to f1 to a. Then for this portion, I'm going to use from a to f2. So here I'll just put open bracket. Then I'm going to subtract the what? I'm going to subtract um, the x coordinates. So you observe that say at f1 you have the coordinates minus c comma 0. So you're going to say minus c minus what?
Let's say that we are putting the square root. So let's say
Come again?
let's see how you get to the square root. There's there's like the method is like let's put it that this then where we wrote the f1 a and f2 f2.
Okay, I said f1 has these coordinates. That's how just the way it is. I was saying in conic section, the letters that we use is A, B, and C. We use C for the focus, we use A for the vertices, and we use B for the core vertices. What I mean by this is our focus, of course, we are going to use the coordinates, which is C. Then our vertices is this one here. That's why I used A here like that. Then for the core vertices is this one here and that one here and that one there. So sometimes you can interchange them. It's not always that you have the vertices on the x-axis. You can have the core vertices in the x-axis depending on the orientation of your conic section. So the reason why I'm using I'm using these square roots here is it's just basically finding distance. We know how to find distance from what topic was that in secondary school? It's is it coordinate geometry or something like that? So at this point you have, yeah, at f1 you have this one, we have those coordinates, and at a you have that, you have those. So you just have to subtract. So it's minus c minus x, then you're going to put squared, then plus. Then here you have 0 minus y, that's just going to be minus y squared, which is just what? Which is just going to be y squared, like that. Then for this portion, you're going to subtract this one minus, sorry, this one minus this one here. How is it going to be? You're going to say x minus, that would be x minus c squared plus, then that would be y minus 0, which is still y squared, like that. Okay, so here what you do from this point is up to you. You just have to break those down, and it's just basic algebra here, guys. So this is going to be, so to simplify such, don't square both sides just now. What you do is that you can get one and take it on the other side. Okay, so one thing that you observe here is that instead of having minus c minus x, because of the squared that I have here, I can make this as what? As x plus c, or c plus x squared plus y squared plus, that's going to be, so here what will happen is that I'm going to say equals to, I'm going to push this on the other side. Okay, so that would be like 2a minus the square root of x minus c squared plus y squared, like that. So now you can go ahead and square both sides. Okay, so you can do that. So square both sides like that. So you observe that this is going to cancel and that's going to cancel. And for this part, and you can even expand this one, I think, in advance. That's just going to be okay. Expanding that one is going to be something like x squared plus that would be x squared plus 2xc plus c squared plus y squared is equals to, okay, so expanding this one because of the squared that you have, you're going to have 4a squared minus open bracket, you're going to expand this one here. Okay, the reason why the like, okay, you just have to expand this. It's just more like you have a here and you have b here, then expand them. You just have to take it step by step. It can look complicated, but it's very simple, believe me. That's going to be x squared here minus 2 um 2xc, then that would be plus c squared plus y squared, like that. Then the other part is going to have minus that would be minus 4a, the square root of everything that you have there, which is your x minus c squared plus y squared. Okay, so before even trying to eliminate that square root again, I can do some cancelling here. You observe that this is just going to be 4a squared minus x squared plus 2xc minus c squared, that would be minus y squared minus 4a, the square root of that's x minus c squared plus y squared. So you observe that uh, this and that can cancel out. What else can we cancel out? Nothing for now. Okay, so now I can move everything else on the other side. Okay, so this is going to be, when you move this x squared, you bring it on this other side. um, how is it going to be? So this is going to be something like 2x squared. That is when I move this one and add it with this one here. Then uh, when it comes to c, when I get this one, I bring it this side, this will be plus 2c squared. Then including the y, that will be plus 2y squared. um, then here you're going to have minus 4a squared is equals to this part here, okay, which is minus 4a, the square root of x minus c squared plus y squared, like that. So one thing that you observe is that the 2 can cancel out. For this one, the 2 can go, 2 can go here, 2 can go, then here you're going to remain with a 2, and here you're also going to put a 2. So this will be 2 here and a 2 there. Are we okay on that one? Okay. So this can seem like a lot of work, but if it's in a quiz, don't even feel lazy, just try to do it. This can even maybe carry up to maybe 4 marks, and you wouldn't want to play around with 4 marks because sometimes it's very scarce to look for marks. So you square both sides, you square both sides. So this is first of all going to be, it's going to be x to the fourth uh, plus um, that's going to be x squared c squared plus x squared y squared minus 2a squared x squared. Ish, this is going to be long, very long. Okay, so that would be plus c to the fourth. um, I think this method is going to be very long. This will be too long. How can I simplify this? uh, okay, give me a minute. Let me try to make it much simple. Okay, so when we cancelled both, when we squared both sides at first, we ended up with x squared plus c squared plus 2xc uh, plus y squared equals to, then the other side gave us 4a squared, and then that was minus open bracket, we got x squared plus c squared, um, plus c squared minus 2xc, okay, then plus y squared, then minus, that's going to be 4a. It looks like it's inevitable to take the wrong root, huh? So that's x minus c squared plus y squared. Okay, so I think, let me not take much of your time. What it is that if you if you break this down, like you just take it step by step, what you're going to end up with is, after you also cancel this square, because we cancelled out the first square, so all is that is remaining is to take what you have here, take it on the other side here. Okay, if you do it on paper, this is much easier. There'll be a lot of space. When you break this one down, take it on the other side, then square both sides so that you get rid of that square root there. You're going to end up with something like x squared c squared is equals to a squared x squared plus a squared c squared, um, c squared plus uh, that's supposed to be plus a squared y squared minus a to the fourth. That's the a to the that was more like the x to the fourth that I had, which was resulting to that. So what you do is that you can pick one of these and take it on the other side. It's just a matter of now knowing how to factor. So I can have my x squared here by c squared, then I'm going to subtract a squared x squared, which is this part here. I've just taken it on the other side. Then this is going to be equals to a squared by c squared plus a squared y squared, minus a to the fourth. So your job right now is just to do the what? Just to do the factoring, um, which I believe by now you are familiar with. So you observe to say you can factor out x squared on this side. That's going to be x squared um, open bracket. That's going to be c squared minus a squared is equals to. So you can factor out a squared from this side. Okay. So what I would do here is that I'm going to I'm going to pair up um, I'm going to pair up this one with this one. Then I factor out a squared. That's going to be like a squared. Okay. Open bracket. Then that's going to be c squared minus a squared, because if you say a squared by c squared, you get this one. Okay, but if you say a squared by a squared, you get this a to the fourth. That's basically what I've done. So that would be plus the a squared by y squared, which is this one here. Then you can divide both sides by this. That's going to be c squared minus a squared divided by c squared minus a squared divided by c squared minus a squared. So this can go, and you can cancel out that one as well. So what you end up with is x squared is equals to a squared plus a squared y squared divided by c squared minus a squared. But remember, we have to end up with that equation. So the question is, how do we do it? Okay, so this is pretty simple. Okay, this is pretty simple. So the question is, how do we get rid of this one that we have here, which is our c squared minus a squared? Okay, so how this is going to be is that I'm going to shift this one and bring it on the other side. Okay, for now, I'm going to say I have x squared minus a squared y squared divided by c squared minus a squared is equals to a squared. But remember, we have to end up with this. It appears like we are very close. We just have to now be smart about it. We get back to the diagram. So this diagram that we have right here, it has a right angle triangle to it. Okay, it has a right angle triangle to it. Someone, they might not really tell you how this one cancels out sometimes, but let me show you how it cancels out. So let me say this point here, we have this as point A, we have this as our origin. Okay, then then we have this other point. Let me name this as point N, or anything, any letter of your choice. So one thing that you observe is that because I was using f1 to a to f2, it basically means for me to end up with 2a, that 2a which is the constant, this is basically a and that is a. That's why this one plus this one was equals to 2a, because this distance is equals to that distance there. That's why I chose to use this one to derive, because it's much simpler. So it basically means what you have here is your what you have here is your a, then what you have here is your c. Why am I putting c here? Is because this is just a distance from this point to the focus there, and the focus has the coordinate, which is what, which is c. Then this one here just simply be what, it will be simple, is just going to be b there. And one thing that you understand is that by Pythagoras theorem, your b squared plus c squared, um, b squared plus c squared is equals to the hypotenuse, which is a squared. So now my goal is to have, I want to write it in terms of c squared minus a squared. So what I'm going to do is that I'll say I'll have my c squared, I'll bring a squared on the other side to be minus a squared. I take b squared on the other side to be minus b squared. So here we're going to come and say this will be um, this is going to be something like x squared minus a squared by y squared divide by, here where instead of having this, I'm going to write what, I'm going to write minus b squared. This will be equals to what, a squared. So what do you do? Multiply both sides by what, by 1 over a squared, so that this one cancels out with this one, it also cancels out with what, with that one there. Then you end up with, so it will be like x squared multiplied by this one, you end up with x squared divided by a squared minus, I mean it's going to be plus actually, because you have a minus and a minus there, so this is going to be a plus. Then this one multiplied by a squared, the a squared is going to cancel out, so this will be y squared divided by b squared equals to a squared multiplied by 1 over a squared, this is just be what, be 1, and this is your equation, which is this one here. So just make sure to say, like, there's there's that part that I didn't finish, like breaking it down. Just take it step by step. You're going to end up with this equation here. I felt lazy to do the expansion. You guys can try to do it, but at least you know how you end up with. So sometimes, just for the sake of fun, you can even try out D, try out C, but I advise you to say, if you are deriving, take into consideration A, because it's much simpler for you to take it to say, okay, I have a right angle triangle here, such that this one is my A, and the reason why I'm guaranteed that it's an A, because this distance and this distance are the same, so it makes my work much easier, you understand? compared to this one whereby you don't know how what the unit, what the value is for that one, and what that one is, because you can clearly see to say this one is smaller than that one, but it still tells you to say no matter whether it's looking smaller, this one is looking bigger, they are just going to end up giving you 2a. But because I'm taking advantage of the fact that I know that this one is equals to this one, I can name this as my a and this one as my a. When I add them, they give me 2a, so that I come up with this right angle triangle, which helps me to cancel out this portion of the uh, part of deriving the equation. Are we clear on that one?
So
Okay, so
yes, yes,
w-
yes.
one thing that you observe is that for this
Salutama pa.
ellipse, the equation that we are deriving, this is when the ellipse is centered at the origin. What we mean is that the center of the ellipse is at 0 comma 0. This is when you have x squared divided by a squared plus y squared divided by b squared is equals to 1. But you might say, hey, wait a minute, this is only when the ellipse is appearing like this, when it's on the x-axis. But what happens if it's like that? This is very simple. So if your ellipse is along the y-axis, if it's elongated on the y-axis, even if you try to derive, you're still going to use the same steps that we took earlier. But when it comes to this one here, okay, when it comes to that one, it basically means, if it's on the x-axis, it basically means your a is greater than your b. Okay, so take this into consideration. If your a is greater than your b, you're on what? You're on the x-axis. Then I believe you're able to guess that if your b is greater than your a, then you're on what? You're on your y-axis. Is that making sense? So even if they give you an equation, let's say for example someone says, okay, you have x squared divided by, let's say you have 9 here, plus let's say y squared divided by 4 is equals to 1. You can clearly see to say my a squared is 9, meaning my a is equals to 3. Then my b squared is 4, meaning my b is equals to 2. You can clearly see to say your a is greater than your b. So before you even do anything, you're able to you're able to have a picture of the orientation of your ellipse. You can tell, oh, okay, because my a is greater than b, meaning it's on the x-axis, meaning even as you sketch, you already know what it's going to look like, because you don't just start sketching without even knowing how it's going to look like. That's why I was advising you to say sometimes look at the equation, analyze it, have a picture of how it's going to look before you even put it on paper, and it's going to make your work much easier, because you know exactly what you are doing. You're not just using guesswork or something. But if it was the other way around, let's say I say x squared divided by, let's say I put 4 here, then plus y squared um, divide by, let's say 16 here is equals to 1. One thing that you observe is that your b is greater than your a, meaning it's along the is along the what? It's along the this is along the y-axis. Okay, so here always keep in mind to say for the ellipse, it's either a is greater than b or b is greater than a. But if your a, you might wonder, if your a is greater, I mean, if your a is equals to b, what do you think you're going to have? I maintain the plus here. Okay, then if my a is greater than my b, what do you think you're going to have? Anyone?
Can you mind let me try to see. I'm there here how you could explain.
No, I was just giving an example to say if you're given this, let's say for example, someone gives you that to sketch, you're able to see to say here you're supposed to have b squared, here you're supposed to have a squared. And considering the fact that your b is greater than your a, meaning your ellipse is going to be on the, it's going to be something like that. But if your a is greater than your b, it's going to be on the x-axis like that. So now I was asking to say, I've only talked about when A is greater than B and when B is greater than A. What if your A is equals to B? What do you think you are going to have?
Is it not a circle? Or
Exact,
is it a
exact,
circle?
exactly. It's going to be a circle because let's just say, for example, here you put, let's say you have something like x squared divided by, let's say, 4 plus y squared divided by 4 is equals to 1. So what it simply means is that this is just nothing but x squared plus y squared equals to 4, and this is just the equation of the circle. So one thing that I'm trying to put across here is that the circle is an example of an ellipse whose c value of c is equals to 0. The circle does not have a focus, the circle only has a center. You understand, right? So the circle is an ellipse whose value of c is equals to 0, uh, simply because the value of a and the value of b are equals to each other. So in this case, for example, if your a is greater than your b and you want to find your focus, we are going to say your focus which is going to be your c squared, will be equals to a squared minus what? Minus b squared. This is just coming from the same triangle that I gave you earlier. So this is how you come up with your focus if your a is greater than your b. But if your b is greater than your a, you're going to say your focus c squared is going to be equals to b squared minus a squared. So now, come to think of it, if your a is equals to your b, meaning your c squared is going to be equals to 0, and that's just a circle, meaning a circle is a conic section whose focus is 0. It only has a radius. Okay, so some other detail that I'd want to put is that when the center is at the origin, which is 0 comma 0, there's also a time when the center is at any other point. Yes, Oscar.
Yes. Just wanted to clarify. You said that when the A is greater than the B, the C squared is equal to B squared minus A squared.
Yeah, so let me just write it here. Wait a minute. So if your a is greater than your b, meaning your equation is on the x-axis, well, that we know at now. So that means if you want to find your focus is going to say c squared will be equals to a squared minus b squared. But if your a not let me see, if your b is greater than your a, meaning you're on what? You're on the y-axis. You're on the y-axis like that, meaning your c squared will be equals to b squared minus a squared. But there is a possibility that your lecturer, what they are going to tell you is this: they are going to say, okay, if it comes in a situation such that your b is greater than your a, what they are going to write for you, I don't know who is going to lecture you, but what they might tell you is that you can write it as x squared divided by b squared plus y squared over a squared. But for me, I never love to confuse myself when it comes to, like, I start swapping and all those things. If I know this fact here, I can graph any connect section. I don't have to worry about swapping a and b because I don't know which one is greater than which one. So there is a possibility that they might give you this one. So if they give you that one, don't get confused. It just means one and the same thing. But for me, I'm more comfortable with this method. Are we okay there now?
Yes, it can proceed.
Okay. So let me give you other properties of the ellipse. Let's say uh, the center is at h comma k, meaning at any other point but the origin. Let's say, for example, it's at 1 comma 2 or maybe 0 comma 5, anywhere but 0 comma 0. Your standard equation, this one is our standard equation, is going to be, if I use this one as the example, this is going to be x minus h squared plus y minus k squared is equals to 1. So this will be divided by b squared divided by a squared. So this one is our standard equation if the center is not at the origin. Are we okay there? So now, having said that, let me put other additional details when it comes to how you find the vertices, the core vertices, and the foci, depending on whether A is greater than B or A is greater than B. So if you're, let me use this. Okay, I can just write it here. If your A is greater than your B, here's how you find your vertices, or the coordinates for the vertices. So the vertices, I'm just going to indicate using V. Your vertices V, they're going to have the coordinates A plus or H. I mean, they're going to have the coordinates H plus or minus A comma K. What it means is that you're going to have a V1 at what? At H minus A comma K, and you're going to have a V2 at what? At H plus A comma K. This is what this one means here. I've just more like fused it in one. Then for the core vertices, for the core vertices, let me just say C vertices, meaning core vertices. For the core vertices, I'll just indicate using CV. The core vertices, they are going to have the coordinates H comma K plus or minus A. Sorry, not A but B. This is when A is greater than B. Okay, so this information that I'm giving you right here is very, very important. You don't need to derive it from anywhere, but you're going to be using it each time you want to graph, because they will need all these details when you're graphing. Then for the foci, which I'll just indicate it using F, is going to have the coordinates H positive or negative C comma K. That is when your A is greater than B. So it basically means if you have your B being greater than your A, it's just going to be opposite. Your vertices V is just going to be H comma K positive or negative A. Then your core vertices, so CV is going to be at your core vertices, they are going to be on the x-axis, so it's going to be like H positive or negative. Wait a minute, this is not supposed to be, no, this is not supposed to be A, sorry. It's supposed to be B, because B is greater than A. So it's supposed to be B here. Then the core vertices are the one that are going to have A comma K there, like that. Then for the focus, or let me say the foci, I'll indicate using F. This is going to be H comma what? H comma K plus or minus C, and this is what you need. Then there's something that is also called the eccentricity. Okay, there's something called the eccentricity. I hope you have written this one here, because I'm going to erase it, but I've managed to record the class actually, so you can still check it out later. So the eccentricity just describes the ovalness of the ellipse. What I mean is that there are those ellipses that are very, very tiny, like it's appearing to be something like that. Then there are those that would be like, that would appear like something like that. If you look at the distance here and the distance on the middle is different. So what describes the ovalness of the eccentric, what describes the ovalness of a conic section is what is called eccentricity. Eccentricity. So this is found when your A is greater than your B, your eccentricity, that is indicated using E, is going to be equals to C over what? C over A. If your B is greater than your A, your eccentricity is just going to be equals to C over what? C over B. Then there's also called there's something that is called the directrix. If you attended the session when you're looking at the parabola, I believe you understand what a directrix is. There is a time when your A is greater than your B, and when your b is greater than than your a. So for this one, I'm going to give you when the conic section, when the center of the ellipse, I mean, is not that the origin is at h comma k. You can indicate it using, for this one it's just going to be x minus h is equals to um, this is going to be equals to a squared divided by c. Okay, but for this one, this is just going to be y minus k equals to b squared over c. And you can manipulate it. You observe to say you can, this can also be equals to um, a over e, and this can be equals to b over e from this one here. If you just substitute where there is c, you put e multiplied by a, and it's just basic algebra there. So this is all about the ellipse. I'm going to send a video where I did some questions, but that same tutorial sheet that I gave you, there are some questions on the ellipse. You can try to go through them, and if you have any difficulties, you are free to give me a call, and I will be able to attend to you. It has actually taken longer than I expected, but yeah, at least we have done something.